This section examines the power booster. A power booster or power brake unit uses a vacuum to multiply the driver's pedal effort and apply that to the master cylinder. This increases the pressures available from the master cylinder. Units on petrol engines use the vacuum produced in the intake manifold. Vehicles with diesel engines cannot use manifold vacuum, so they are fitted with an engine-driven vacuum pump. The most common booster now operates between the brake and master cylinder. It increases the force that acts on the master cylinder. Whenever the pedal is depressed, the power brake unit assists the driver. The level of assistance depends on the pressure applied. When the driver moves the brake pedal pushrod, it transmits movement through the power unit to the master cylinder piston to apply the brakes. It also operates a control valve that admits air atmospheric pressure to the rear of the unit. How it works depends on the position of the pushrod. A hose connects the intake manifold to a vacuum check valve on the power unit. With the engine running, the vacuum in the intake manifold is used to evacuate the power unit. This valve is held off its seat and a vacuum is produced in both chambers of the unit. The chambers are separated by a flexible rubber diaphragm attached to the diaphragm plate. It is held in the off position by a diaphragm return spring. The master cylinder pushrod and the control valve assembly are centrally located on each side of the plate. As the brakes are applied, the pedal pushrod and plunger move forward in the diaphragm plate. This brings the control valve into contact with the vacuum port seat. It closes the vacuum port, sealing off the passage connecting the chambers. Further movement of the pushrod and plunger moves the air valve away from the control valve to open the atmospheric port. Air at atmospheric pressure comes into the air filter and passages and enters the chamber at the rear of the diaphragm. The difference in pressure now on both sides of the diaphragm moves the diaphragm plate forward, and it takes the master cylinder pushrod with it. Hydraulic pressure builds up in the brake system to operate the brakes. As pressure rises, a counterforce acts through the master cylinder pushrod and the reaction disc. This counterforce acts against the plunger and pedal pushrod. It tends to move the plunger slightly to the rear, and it closes off the atmospheric port. If the vacuum source is interrupted, then, as the pedal is pushed down, the pedal pushrod and plunger assembly come in contact with the reaction disc. This forces the master cylinder pushrod forward to operate the brakes. The pedal force needed then is much greater than with vacuum assistance. During application, the reaction force against the valve plunger works against the driver to close the atmospheric port. With both the atmospheric and the vacuum ports closed, the power unit is in a holding position. It stays this way until increased pedal force reopens the atmospheric port, or a drop in pedal force reopens the vacuum port. With the force on the pedal held constant, the valve returns to the holding position. But if the pedal is fully applied, the plunger moves away from the control valve to open the atmospheric port and give full power application. When the brakes are released, vacuum returns to both sides of the diaphragm, so the spring releases the brakes. When the engine is switched off or stops for any reason, no vacuum is available. The vacuum remaining in the booster, held by the non-return valve, will provide for at least one power-boosted application. After this, The brakes will still operate, but without power assistance they require more effort from the driver.